Okay, let's review linear equations in two variables. This is stuff that you should have learned in Algebra 1, so I'm going to go through it rather quickly as a refresher. If you need further explanation, you can always go to the Algebra 1 page and look up the unit, I believe it's Unit 3 for linear equations. So there's different forms for linear equations. One of the forms, probably the most common, is called the slope-intercept form equation of a line. And it looks like y equal mx plus b. We'll make a little arrow here so we can point to things. And in that equation, there'll be a number here where m is at, and that represents the slope of the line. And there'll be a number here, and that'll represent the y-intercept. So let's look at an example. Here's an equation. It's in slope-intercept form, y equal 4/5 x minus 6. Well, right away from this form, we know the slope of the line is 4/5, and the y-intercept is -6. And if you look at the graph of this, it goes through the point 0, -6, that's your y-intercept, and from any point to any other point on the line, the ratio of the rise over the run is 4/5. Another form that we should be familiar with is what's called the point slope form. And in the point slope form, that looks like y minus y sub 1 equals m times the quantity x minus x sub 1. Now notice, the y and the x are variables in our equation. The y sub 1 will be a number, depending on the particular situation. The x sub 1 will also be a number, and m is once again the slope. So x sub 1, y sub 1 is a point that's on the line, and m is your slope of your line. So let's look at an example here. Once again, we have another line graph. The equation for this line in point slope form could be y minus 3 equal 2 times the quantity x plus 4. Now notice, -4, 3 is just one point on this line. There's an infinite number of points. So we could pick any point on this line and replace the x and the y coordinates right here. And even though the equation looks different, it still represents the same line. So in this case, the point -4, 3, you get that from the opposite of this. It's a +4, so the x coordinate is -4. And then -3, the opposite of that is +3. And then your slope is 2, or as a fraction, 2/1. So those are the two most commonly used equations for lines, but we also have two more. One of them would be the standard form, and that looks like this: ax plus by equals c. A couple of constraints on this. Sometimes you can simplify the equation. So first of all, always make sure that a is a positive integer, and a, b, and c are relatively prime integers. So that means if you have any fractions, you need to multiply by the least common denominator to clear all your fractions first, and make sure that they have no common divisors. So example, if that was a 2x plus 4y equals 6, well, we could divide everything by 2, and it would still be the same equation, just simpler. So you want to make sure that all those two coefficients and a constant are relatively prime. An example of that would look like this: 3x minus 2y equal 12. In this case, the a is 3, the b is a -2, and the c is 12. Also, a couple other things to point out, that the x-intercept here, in this particular case, is 4, so the point 4, 0. The x-intercept is going to be the ratio of c over a. C was 12, a was 3, 12 divided by 3 is 4. Okay, and the reason being, to find an x-intercept, you set y equal to 0, and so if we plug in 0 for y here, we wind up with just 3x equal 12, and when you solve that, you do the 12 divided by the 3, or the c divided by a. Similarly, if I want to find the y-intercept, we would set the x equal to 0, and then when we solve -2y equal 12, we're going to take that 12 divided by -2, so in other words, c divided by b, and that would give you your y-intercept. Some books use the standard form in some of their problems, and some texts will use what's called the general form. The only difference is where the constant is at. So in the standard form, the constant, if I can fit them, no, can't fit them on the same screen. In the standard form, the constant is on the right side of the equal sign by itself. And in the general form, it's over with the x and y variables. So not a big deal though. Let's look at a few examples and work through these just to make sure you remember how to work some of the types of problems. Find the slope-intercept form of the line with slope negative 3/4 and a y-intercept of 1. First thing I do is identify what should my answer look like. Slope-intercept, that's y equal mx plus b. I know the m stands for the slope, and they gave that to me. So y equals negative 3/4 times x, and then the y-intercept is the b, so that's just 1 in this case. So this was the easiest problem you could have. They just give you the m and the b, and you write out your equation. Okay, what if they said find the slope-intercept form of the line? Once again, slope-intercept form, so I'm going to write down what my answer should look like. And the slope is 2, so we have the m. So y equal 2 times x plus, and we don't know the y-intercept, so I'm just going to write plus b for now. But they do tell me that it contains this point. So that should be enough information to help me figure out what b is. So let's look at our equation. Remember, a point, the coordinates are x comma y, so I can plug in 1 for the x, and I can plug in negative 6 for the y, and then I should be able to figure out what b is equal to. And so in this case, subtract 2 from both sides, we get b is negative 8. So I had to do a little bit of extra work, but it wasn't so bad. So my final equation in slope-intercept form, y equal 2x minus 8. All right, so far not bad. What other types of problems could they give us? Find the slope-intercept form of the line, y equal mx plus b. That's what my answer should look like. This time I don't know the slope, but I do know the y-intercept. 0, 5. Picture plotting that. 0, 5. That's 0 left or right, 5 up. That gives me my y-intercept. So I know the y-intercept is 5. So let me at least fill that in. So y equal mx plus 5. Okay, now I don't have the slope though. They did give me 2 points. So we remember, wait a minute, I know how to calculate slope. M is equal to the rise over the run, or the difference of the y coordinates divided by the difference of the x coordinates. So I can use these 2 points to do that. So 5 minus, careful, minus a negative 1. That's the difference of my y coordinates. And 0 minus 2. Now I know what you might be thinking. Well, wait a minute here. You wrote y2 minus y1. Isn't this y2 and that y1? Doesn't really matter. I can think of this as my x2, y2, and this is my x1, y1, or vice versa. It doesn't matter. We just have to subtract the y coordinates on top and the x coordinates on the bottom in the same order. So we can't switch it up. I couldn't have done 5 minus negative 1, but then switch and start with the 2 here and do 2 minus 0. That would cause a problem. We get the opposite sign for our answer. All right, so this simplifies to 6 over negative 2, which is negative 3. So now I have my slope. So now I can finish writing my answer. Y is equal to negative 3x plus 5. So that took a little more work than the other problems, but still not too bad. What else could they give us? Find the slope-intercept form of the line which contains the point 6, negative 1 and the point negative 2, negative 5. All right, so first of all, what does my answer look like? Y equal mx plus b. All right, do I know the slope? No. Can I calculate it? Yes. They gave me 2 points so I can figure out the slope. Did they give me the y-intercept? No. So I'm going to have to figure that out as well. So we have y equals, let's first of all calculate our slope. M is the difference of the y values, negative 1 minus a negative 5, over the difference of the x's, 6 minus negative 2. Negative 1 plus 5 is 4. 6 minus negative 2 is 8. So my slope is 1/2. So I can fill that in. I still don't know what b is though. But remember, this was like one of the other ones we just did. I can use one of the points, doesn't matter which one. Let's use this one. And I can substitute 6 for the x in my current equation and negative 1 for the y. And I should be able to figure out what b is. So negative 1 goes in for the y, equals 1/2 times x, which I plug in the 6 for, plus b. So I've got negative 1 equals 3 plus b. b is equal to negative 4. So now I have my m, I have my b. I can go ahead and write the answer. If you write plus negative 4, that's fine as well. And that's it. So just to show you, you start off with the simple idea, slope-intercept form, m and b, and then there's always going to be enough information in the problem to help you figure out m and figure out b if they don't give it to you directly. Let's look at 2 more examples. Find the point-slope form of the line. Point-slope form, this is different. What does that look like? Point-slope was y minus y1 equals m times x minus x1. And I need the slope, which they gave to me. And I need a point, which they gave to me. So I'm just going to plug in those values. So y minus the y-coordinate of my point, I'm negative 2, so that becomes plus 2, equals my slope, negative 3/4, times x minus the x-coordinate of my point they gave me, which was 4. And that's it. We leave it in that form because that's the form they asked for. Find the point-slope form. Okay, what does that look like? Y minus y1 equals m times x minus x1. And what information did they give me? Did they give me the slope? No. But they did give me 2 points. So first let's calculate the slope. Difference of the y value. So it doesn't matter which. I'll start with the 10, 1. So 1 minus a negative 1, that's the difference of the y's, over 10 minus 6, difference of the x's. So that gives me 2 over 4, which is 1/2. So I have my slope, y minus equals 1/2 x minus, and now I have to plug in a point. Now they gave me 2 points, so it doesn't matter. I could use either one. Let's use the 10, 1 point. That would be y minus 1. It's 1/2 times the quantity x minus 10. And so that is one possible correct answer. On the other hand, we could have plugged in the other point, 6, negative 1, and it would become y plus 1 equals 1/2 x minus 6. And that would also be a correct answer. So either one of those would be acceptable. Find the standard form. Standard form, what was that before I even think about what I have to do? Standard form was ax plus by equals c. A had to be a positive integer, a, b, and c are relatively prime integers. So from example 3, so I guess we got to go back here. Let's go to example 3. What was our answer? Here was our answer. Let's clone that. Let's send it over here. I think I sent it over there probably. There it is. Okay. And now what I have to do is just rearrange this so it's in standard form. So how does that work? Well, we need to get the x and the y on the left side. So I can add 3x to both sides. And then I have the y already there. And I'll leave the 5 on the right side. The x coefficient 3 is positive. We have all integers, no decimals or fractions. So that's it. Okay, let's do one last one. Find the general form of the line from example 6. General form, what did that look like? That was ax plus by plus c equals 0. By the way, in this last example, A was 3, B would be 1, and C would be 5. All right, so we want to take the answer from 6, which we had 2 answers, so, I don't know, let's just take this one, if it stays together. Let's try there. Boom. Put that over there. All right, the general form. Well, the first thing we're going to need to do is get rid of your parentheses. So we have y plus 1 equals 1/2 x minus, and when we distribute, that'll become a minus 3. All right, let's move the 1/2 to the other side. So we're going to have negative 1/2 x plus y. Let's get that, oops. Let's also add the 3 to the other side. And when we combine that with the 1, we'll get plus 4 equals 0. Now, the only issue here is we have a fraction, and that coefficient of x not only is a fraction, but it's negative. So I can take care of that by multiplying everything by negative 2. That's going to give me a positive 1x minus 2y minus 8 equals 0. Coefficient of x is a positive integer. There's no decimals or fractions. And 1, negative 2, and negative 8 are all relatively prime. Check.